Have you ever just stopped and wondered, what's really holding AI back? I mean, we see these unbelievably powerful models pop up all the time, right? But the real revolution, the next big leap, it isn't just about making them bigger. It's about building all the invisible stuff, the infrastructure that lets them actually work together in the real world. So today, let's pull back the curtain and take a look at this unseen scaffolding. And it's kind of a weird paradox when you think about it. We've got AIs that can write incredible poetry, that can code complex software, but they still feel so clumsy, so disconnected from each other, and from all the tools that we use every single day. So what's the deal? Why is that? Well, the best way to picture the problem is like this. Each AI model, or what we call an agent, is like a genius specialist, a world-class expert, but they're all locked in separate, soundproof rooms. They can't talk to each other, they can't coordinate on a project, and all that incredible potential is just stuck, crippled by this basic lack of connection. And that brings us right to the first massive hurdle, what I'm calling AI's big communication problem. It's truly a digital Tower of Babel out there. You have agents from all these different companies and platforms, and they just flat out can't talk to each other. And trying to get them to use real-world tools, forget about it. It is a chaotic, totally unreliable mess. Okay, so to fix this, a couple of new open standards are starting to pop up, and you're gonna wanna know them. A2A and MCP. So A2A, which stands for agent to agent, is all about getting agents to talk to each other. Simple enough. Then there's MCP, the Model Context Protocol, and that's for getting agents to connect with all the tools and data out there. Now here's the key thing to get. They're not competing. They're totally different tools designed to work together to solve this big problem. So let's start with A to A, the agent-to-agent protocol. Honestly, the absolute best way to think about this is like creating a universal English for AI agents. It's a standard language, a common ground, so an agent built by, say, Google can just seamlessly work with one built by some tiny new startup. It's all about finally breaking down those walls between the rooms. So how does it actually work? Well, it's got a few really simple parts. First, there's the agent card. You can just think of it as a digital business card. It tells all the other AIs, hey, this is who I am and this is what I'm good at. Then you have a client. That's just the app that needs something done, and it sends a task over to a server, which is the bot that actually does the work. See? It's just a really simple, super standardized way to hand off jobs from one agent to another. But what about all the tools? You know, the databases, the APIs, all that stuff. That's where MCP, the Model Context Protocol, comes in. Right now, trying to connect an AI to every possible tool is just pure chaos. MCP acts like a universal adapter. It creates one single standard language for the AI to interact with any tool, which finally makes the whole process scalable and, not a complete nightmare. Okay, so with A to A and MCP, our agents can finally talk to each other and they can use all the world's tools. Awesome. But that brings up a brand new question, doesn't it? How do we make sure they actually have something smart to say in the first place? And that takes us to the next big challenge, training. For years and years, the mantra in AI has just been more data is better. Just pile on more data and the models will get smarter. But we're starting to hit a wall with that approach, and it's forcing a really important shift in thinking. We need to train smarter, not just harder. And this isn't just a feeling, there's real research showing a plateau effect. Just look at this quote. It explains that after a certain point, just jamming more and more data into a model doesn't really help. Performance either stagnates, or believe it or not, it can even get worse. The old brute force approach is officially running out of steam. So what's the solution then? Well, there's this fascinating new framework called GRAPE, and its core idea is so simple, but it is so powerful. It says that the best data to train a model isn't just any high-quality data. No, it's the data that best fits what the model already knows, the information that really aligns with its pre-trained worldview. And here's a look at how it works in practice. So for any given question or prompt, GRPE goes out and gathers a whole bunch of different possible answers. Then, and this is the clever part, it uses the base model itself as the judge. It has the model rank all those answers and pick the one it finds most probable, the one that just makes the most sense based on everything it already knows. And only that single best fit answer gets used for training. And the results? They are absolutely stunning. Get this, in one test, a model trained on a huge data set, we're talking 3 times the data, it scored a 39.4 on a performance benchmark. But the model trained using the GRAPE method, using 3 times less data, scored a 56.7. That is a massive 17.3% performance jump, all from just being way smarter about which data it learns from.
So we're making these models learn way more efficiently. That's a huge win. But what happens when we try to move from general knowledge to teaching these AIs how to perform specific actions? Well, training specialized agents to actually do things in the world, that introduces a whole new level of chaos. And this time, it's all in the data itself.
Which brings us to our third and final big challenge for today, taming the data chaos. Because right now, the world of agent training data is, frankly, like the Wild West. Everybody's got their own system, their own format, and absolutely nothing works together.
And there are really three core problems here. First off, creating good, step-by-step data to teach an agent is just incredibly complex and expensive. But the real killer, the thing that messes everything up, is heterogeneity. Every single dataset has a different format, a different structure. And because of that, you can't combine them, you can't mix and match them, you can't even really compare them to build more powerful agents.
The solution here is another protocol, this one called the Agent Data Proton, or ADP. And I want you to think of this one as a Rosetta Stone for agent data. It is a new standard that's designed to translate all of these different, chaotic, messy datasets into one single, unified, structured format that any agent can finally understand.
And the ADP process is a really straightforward three-stage pipeline. First, it parses the raw data from pretty much any source you can throw at it. Second, it standardizes all that data into a universal format that's ready for training. And then finally, it runs a bunch of quality assurance checks to make sure everything is clean and consistent and ready to go. It's a system for turning total chaos into perfect order.
Okay, so let's connect the dots. We've just looked at three totally distinct problems and three really powerful solutions. So how do all these pieces fit together to actually build the future of AI?
Well, when you put them all together, they form the three essential pillars of this new AI infrastructure. You've got ADA and MCP, which provide the common language for agents to communicate and use tools. You have GRAPE, which makes sure that the models learn super efficiently. And you have ADP, which provides the standardized data they need to learn how to act in the world.
This is that unseen scaffolding that we were talking about at the very beginning. Look, it's not as flashy as a new chatbot, I get it, but it